So welcome to another video in chemistry. On this time we are looking at percentage yield, which I sometimes love to abbreviate as percent yield. So you are going to see me use maybe an expression percent yield, just a short abbreviation as I write. So exactly what is percentage yield? Well, when we talk about percentage yield, it is simply the ratio of the actual yield to the theoretical yield, and you just express it as a percentage. So we can say percentage yield, is the ratio. So it's the ratio of the actual yield to the theoretical yield expressed as a percentage. So that is what we simply call as being percentage yield. So it is simply a ratio of the actual yield to the theoretical yield, then you just express it as a percentage. So therefore the formula that we apply that you need to remember is that when it comes to the percentage yield, it will be equal to the actual, so it is the actual yield over what we are calling as being the theoretical yield. Then we just multiply this by 100. So that's a percent. That's the formula that we use as being the percentage yield in our calculation. But the question is maybe that we can ask ourselves is, what exactly is the yield when we talk about the yield? Well, when we talk about yield is simply the amount of product formed when substances react. So that's what we call yield, what you get at the end of something. For example, you buy a 10 kg bag of mealie meal, you plant it, then you tend to harvest. So what you get is what we call as being the yield. So yield, we can say, is the amount of product. So we can say is the amount of product formed when substances, in this case we're talking about reactant, when substances react. So the key word, the amount of product that you get, is what we simply call as being yield. But what then are we talking about when we say actual yield? What is actual yield? Well, the actual yield in this case, sometimes when I'm finding solutions, I love to call it AY, but of course you should write the complete word. So actual yield is simply the amount of product obtained at the end of a chemical reaction. So we can say is the amount of product obtained. So the amount of product obtained at the end of a chemical reaction. What do I mean at the end of a chemical reaction? Well, imagine you are carrying out a reaction in the laboratory. You are carrying out a reaction, for example, you are reacting magnesium with hydrochloric acid, then you come up with magnesium chloride, that's the salt. Of course, hydrogen will escape. So now what you get when doing it experimentally, when carrying out experimentally, the amount of product that you get when you are doing experimentally in the lab experimenting, that is what we call as being the actual yield. All right. On the other hand, when you calculate the same product, when you calculate it from a balanced chemical equation, that is what we call as being the theoretical yield. But of course, let me wind up with this one. Sometimes the actual yield is also known as being experimental. So we call it sometimes as being experimental yield. Why? Because it is what we get from an experiment when we do experimentally. So we call it as being experimental yield. On the other hand, we can talk about what we are calling as being the theoretical yield. Like I said, the theoretical yield is the amount of product. So this is the amount of product that we get from a balanced chemical equation. So when you calculate from a balanced chemical equation, that's what we call as being the theoretical yield. Okay, so is the amount of product we can say obtained. So maybe we can say obtained, in a chemical calculation. Maybe I can say in a chemical calculation. So when you are calculating the amount of product that you get is what we call as being the theoretical yield. Now the theoretical yield, sometimes is also known as being the expected. It is also called as being the expected yield. Now I want you to take note of something here. You are going to find that the theoretical yield will always be greater than what we are calling as being the actual yield. It will always be greater. Why is that going to be greater than the actual yield? The theoretical yield, you are just calculating from a balanced chemical equation, but the actual yield is what you get from an experiment. So what you get from an experiment, when you're carrying out an experiment, sometimes not all reactants are going to react completely, and not all the reactant that you're going to pour, some of them will remain clinging to the walls of the apparatus you have. So you are not going to have everything that you need. No wonder the theoretical yield will always be greater. Let me show you how you can apply this formula: percentage yield, actual yield over theoretical yield times 100%. Let's see how we can apply that. So I have a question with me here. Let's quickly try to go over this question and see how you are able to answer using that. All right, remember in the previous video I talked about how you can calculate the limiting reagent. It is possible, but this time the question I think is direct, so we don't have to struggle with that. So it says the equation below shows the process of extraction of iron. So that is what they tell you. That's the equation they have given you. So iron 3 oxide reacting with carbon monoxide to produce iron and carbon dioxide. So that's what we have. Then it says if you start with 150 grams, so it says if you start with 150 grams of iron 3 oxide as the limiting reagent. So our iron 3 oxide, they have already told us, is the limiting reagent. No need to worry. So we'll use this to determine any amount of product we need. What is the theoretical yield of iron? So you are comparing this iron 3 oxide to just the iron. So let's calculate the mixture of this guy from this balanced equation. Of course, if you look at the mixture quickly, let me try to do that. Iron 3 oxide, there are 2 ions, so 2 multiplied by 56, which is the atomic mass, plus oxygen, there are 3 times 16. That's the atomic mass of oxygen. So that will give me 112 plus 3 times 16. That gives us 40. That gives us a 48. So if you add the 212 plus 48, that is giving me 160. The ion there, remember the ion there are 2 ions that are there, so it is 2 multiplied by 56, which will give me 112 grams. That's what we mean. So from the balanced chemical equation, the mass of iron is we can simply say 160 gram 160 gram of iron 3 oxide produces what mass of iron from the balanced. So please, when you are calculating masses in a balanced chemical equation, even the numbers in front work. Unless you are just calculating the mixture, we only use the formula, not numbers in front. So that will be 112 grams of iron. So 160 grams of iron 3 oxide produces 112 grams of iron according to the balanced chemical equation. Remember, it says if you start with 150 grams of iron 3 oxide. So I'm going to say, suppose I now use 150 grams of this iron 3 oxide. Then what mass of iron do I need? So you cross multiply. This times that will give you 160. X is equal to 150 multiplied by 112. To find x, I'll divide 160. What I do this side, I'll do it the other side. Therefore, my x will give me, if you try to do that on your calculator, 150 multiplied by 112. The answer you get, you divide it by 160. I'm simply getting a 105. So that 105, so I have 105 grams of iron. So this 105 grams of iron, this we have obtained from calculating the amount of product we have obtained. This is what we call as being the theoretical, that is the theoretical yield. So if you have been calculating from a balanced chemical equation, the amount of product you have been calculating is what we call as being the theoretical yield. So that's the way we calculate the theoretical yield. So it is simply 105 of the iron there. All right, we move on to the B part there. According to the B part there, it simply says, the B part there says, if the actual yield of iron was that. So remember, they have given you the actual yield. What is the percentage yield? So remember, I said percentage yield is equal to the actual yield over the theoretical yield, then multiply this by 100, which is a percent there. So actual yield, remember the actual yield, they have told us if the actual yield is that, so it is 87.9 over the theoretical yield that we got in part A was 105, then multiply this by 100, which is a percent. Of course, if you carry out your calculation there, 87.9 times 100, what you get divided by 105 to one decimal place, I'm simply getting 83. I'm getting 83.7%. So 83.7% of iron. So this is what we are calling as being the percentage yield. So that's the percentage yield of iron that was obtained. Well, this marks the end of my video. Thank you so much, and look forward to another video where we are going to talk about percentage purity.